In this lesson, we are going to study about permutations and combinations. How do you count arrangements? Sometimes you need to count the number of ways you can choose some of the objects in a set. You need to count the number of ways you can choose some of the objects in a set. You must be careful to decide whether the order of the objects matters. So when you're arranging these objects, you must be careful whether the order of arrangement matters or not. For example, let's take Alice has 3 favorite snapshots. Let us label this snapshot as recreation when he's coming back from sports. Let us label this snapshot as victory. He has won something. And let us label this snapshot as family snapshot. Now Alice has 3 favorite snapshots. In how many ways can Alice choose 2 of her 3 snapshots for this double frame? So he has a double frame. He has to choose any 2 of the snapshots to place it in the frame. So in how many ways can he choose the snapshots? Remember, this is recreation, victory, and family snapshot. One snapshot goes on the left and one on the right. So the order of the snapshots chosen is important, because if he places one snapshot on the left, he cannot place the same snapshot on the right. So the order of the snapshot matters. So let us use the counting principle to know the number of choices he has. Now let's take what are the choices he has for the left side of the frame. He can put either this or this or this. So he has 3 choices to place any of the snapshots on the left frame. This is the left frame and this is the right frame. Once he places one snapshot in the left frame, how many snapshots is he left with to place on the right frame? He has 2 snapshots to place in the right frame. So the choices for the right frame is 2. So the total number of choices will be 3 times 2, 6. So the order of the snapshot matters in this lesson, in this problem. Let's look at it in another way. In how many ways can Alice choose 2 of her 3 snapshots for this double frame? In the left frame and in the right frame. One snapshot goes on the left and one on the right. So the order of the snapshots chosen is important. So let's take this to be his victory, recreation, and family snapshot. So let's make a list of the arrangement. He can either choose victory in the left and recreation on the right. That's one way of arrangement. Or he can choose recreation on the left and victory on the right. Another way of arrangement. And so on. So there are 6 ways to choose. It's the same whether you use multiplication principle, counting principle, or you choose the listing principle. In how many ways can Alice choose 2 of her 3 snapshots to mail to her grandmother? Now he wants to mail 2 of the 3 snapshots to her grandmother. This is victory, recreation, and family. In order of the snapshots mailed to Alice's grandmother, the order of the snapshot does not matter. So whichever order he places the snapshot, that does not matter. So VR, whether he mails VR, represents the same pair as RV. It's the same thing because the order does not matter. Since the list in example A shows each pair twice, Let's look at this. Look at this list. It is showing each pair twice. For example, you have VR and RV. If the order does not matter, VR and RV is the same. So since the list and FV is same as VF and RF is same as FR. So since the order does not matter, we can either easily remove each one of them. So what is the total number of choices he has if the order does not matter? It is 3. So 6, there were 6 choices over here. Since it is repeated, remove the repetition, divide by 2. So you have 3 ways to choose. In how many ways can Alice choose 2 of her 3 snapshots to mail to her grandmother? Victory, recreation, and family. The order of the snapshots mailed to Alice's grandmother does not matter. So VR represents the same pair as RV. So let's do the same problem by making a list. So either he can mail VR or VF or RF. So there are 3 ways to choose. When order is important, as in example A, where you are arranging the snapshots in a frame, you are counting permutations. So when order is important, you are counting permutations or arrangements. When order is not important, as in example B, where you are mailing to the grandmother, you are counting combinations. Suppose Alice adds a 4th snapshot of a family picnic. Let's take this as family picnic snapshot. In how many ways can she arrange the 4 snapshots in a row on her wall? So we know this is this is recreation, victory, and family. And he has added another one, family picnic. So now he wants to arrange these 4 snapshots on the wall. So is the order important? Yes, because if he places the recreation over here, he cannot place the recreation anywhere else. So the arrangement is very important. So let's use the counting principle. If he has to put a snapshot over here, how many choices he has? He can put either R or V or F or FP. So he has choices for the first position. The first position over here. He has 4 choices. He can put any one of the 4 frames, 4 pictures. Now in the second frame, since he has already put one picture in the first frame, now how many choices he has to put in the second frame? How many choices of snapshots he has to put in the second frame? He has 3 choices. In the third frame, now since 2 are already gone, he has 2 choices. And in the fourth frame, there's only 1 snapshot left to be put. So he has 1 choice. So multiply all of them and you get the total number of possible arrangements, 24. Suppose your class has 25 students. If your teacher wants to know how many ways she can use 3 students for a team project, would the order matter? She wants to arrange 3 students. She has 25 students. She is choosing 3 for a team. Will the order matter? No, because she can pick any student and any 3 students and form a team. The order does not matter. But suppose if your teacher wants to know how many ways she can choose 3 students to serve as president, secretary, and treasurer of the class, Would order matter? Explain your thinking. She wants to choose 3 students, one for president, one for secretary, and one for treasurer. Out of the 25 students she has, will the order matter? The order of choosing students? Yes, because president, secretary, and treasurer are 3 independent positions. So order matters. Because if a student becomes a president, he cannot be the secretary at the same time and he cannot be the treasurer at the same time. So the order matters. So is this now a permutation problem? Counting? Yes. So this is permutation. Permutation. This is permutation because order matters. In example C, where is example C? Let's look at example C. This one. Suppose Alice adds a 4th snapshot of a family picnic. In how many ways can she arrange the 4 snapshots in a row on her wall? That was example C. In example C, is example C an example of permutation or combination? Does the order matter in arranging the 4 snapshots on the wall? So it's a permutation. The order of the pictures is important. Use V, R, F, and P to represent the Alice's 4 snapshots. This is the picnic one. Make a list of all the arrangements that start with V. So your arrangements, V snapshot must be first. So what are the different types of arrangements you can make? You can make VRFP, VRPF, VFRP, VFPR, VPRF, VPFR.